Hello everyone. In this video, we'll be solving problem 207 course schedule. The problem statement is there are a total of num courses that needs to be taken labeled from 0 to num course minus 1 or n minus 1 and a prerequisite array that suggests which core needs to be taken first to complete the current course. We need to return true if we can finish all of the courses or else return false. In example number 1, there are two courses and one prerequisite. Course number 1 can't be taken until course 0 is complete. Because 0 does not have a prerequisite, we can first check course 0 and then 1. As we are able to take both of the courses, the output is true. In example number 2, there are two prerequisites given to us. One is a prerequisite of 0 and 0 is a prerequisite of 1. So there is a deadlock situation here where neither of the courses can't be taken, so the output is false. This is a classic example where we can use a graph traversal approach to solve this problem. Now let's switch to whiteboard and discuss how we can use graph traversal technique to solve this problem efficiently. Let's use this as an example. We are given a total of 4 courses that we need to see if we can fit into our schedule. Now these are the prerequisites. Now let's start to map these into a graph format. Starting with the first entry, course number 1 has a dependency or prerequisite of course 0. Course number 2 has a prerequisite on course number 1. Similarly, we'll move on to the next two elements where course number 3 has a prerequisite on course 2 and course 1. 3 should appear here where it has a prerequisite on 2 as well as on 1. Now this is how the graph would look like if we try to map all of these prerequisites. To start solving the problem, we need to first identify if there is any course in the entire collection who does not have a prerequisite. Here we have course number 0 which do not have any prerequisite. So we can start by removing 0 from the collection. And all of the courses that were blocked due to course 0 are now available, which is course number 1 in this scenario. Once course number 1 is out of the picture, course 2 is now unblocked, and similarly course 3 will be after that. So the sequence of courses would be to first take 0, after that take 1, then 2, and after that we can take 3. And as we were able to take all of the courses, the output will be true. I hope you were able to understand how we built this graph and used it to solve the problem by applying a DFS-based traversal. Now to solve it programmatically, we need to build this graph using a hash map where key will be the current course and the value will be an array of all of the courses that are a prerequisite. Once we map all of the prerequisites into a hash map format, we can run a loop on all of the entries in the hash map, check if the corresponding keys value have any prerequisites pending. If yes, then we should skip that and continue with the remaining ones, and if not, then we can close that or remove all of the prerequisites so that we can say that the course is complete or it is scheduled. Let's run a quick simulation to get a better idea. I've created an empty hash table with no values. For course number 0, there are no prerequisites, so this collection will be empty. For course 1, 0 is the prerequisite. For 2, it is 1, and 3, 1 and 2 are the prerequisites. Now that we have the table ready, we can start traversing through all of the entries and see if the corresponding values are empty or all of the courses are already complete. If no, then we'll run a nested loop on all of the prerequisites to see if the courses have been scheduled. Starting with the first entry, course 0 do not have any prerequisites, so it can be scheduled. So we'll move on to the next entry, which is course number 1. Course 1 has a prerequisite of course 0. So we'll do a lookup on course 0 in the collection. Because course 0 do not have any prerequisite, it means it is already scheduled, so which unblocks course number 1. To avoid duplicate calls in future, we'll remove 0 as a prerequisite of 1, which will tell us that course 1 is ready to be scheduled. We'll repeat the same cycle by incrementing the pointer and looking at the next course, which is course number 2. Course number 2 has a dependency on 1. Now we'll check if 1 is already been taken. So we'll repeat the same cycle by checking it inside the same collection to see what is the status of course number 1. Because its corresponding value is empty, It means course 1 has already been taken.
So we'll remove 1 as one of the prerequisites of 2.
So now course 2 also do not have any prerequisites remaining or pending. Moving on to the next one, which is 3. It has 2 prerequisites, 1, 2.
We'll repeat the check of looking up these individual courses into the Hashmap table, verify if they have been taken. If yes, then we'll remove it from the collection and mark 3 as scheduled as well.
And as we were able to take all of the courses, our output will be true. There is one edge case that we have not yet discussed, where there could be an infinite loop. Now with this new prerequisite requirement, 0 has a dependency on 3.
But 3 has a prerequisite of 1, 2. So there are no courses in the entire table which can be taken as is without having any prerequisites. So this is that case where there is a deadlock and we should return false. To avoid falling into the infinite loop trap, we'll use a variable called visited set, which will be of type has set, and it will record all of the courses that we have visited during the iteration. During the recursion, if we see a course which has already been visited, we will stop the iteration and return false immediately.
With this solution, our time complexity is O of n plus p, where n is the number of courses given to us and p is the size of the array of all of the prerequisites. This is because we are running an iteration on all of the courses to build the hash table and then checking all of its corresponding prerequisites to make sure all of the courses are either covered or visited or pending. Similarly, the space complexity is also O of n plus p, as we are using this hash map to record all of the courses and its corresponding prerequisites, and using this visited set array to keep tabs on all of the courses that we have visited. I hope you were able to understand the explanation. Let me show you how we can implement this using C#. Here's the implementation in C#. I'm starting by building my hash table by iterating through all of the courses and then running a for loop across all of the prerequisites given to us in the input. After that, I'm initializing two arrays to record the nodes that have been visited and the courses that have been completed during the iteration. Post initialization, I'm starting a for loop to run through all of the courses and to check if the corresponding course is complete, and if not, then calling the hash cycle method to check if all of its prerequisites are completed. Inside the hash cycle method, I first check if the course have already been visited. If yes, then we return true, or if the course have been completed. If yes, we can return false, which means we have not found any cycles. After that, I am running a for loop on all of the adjacent nodes of the current course, that is the prerequisites, and recursively calling hash cycle method. If the hash cycle method do not return true, then we reset the visited course to false, that is backtracking approach, and mark the course as complete. If any of the iteration for hash cycle calls returns true, it means that there is a cyclic dependency which cannot be broken, so we return false in that case. If no, then we continue with the run, and at the end we'll return true. This code, when submitted on LeetCode, beats almost 100% of the submissions in terms of runtime and 63% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.